Hello everyone, my name is Yura Kuratov, and today I will tell you about how to implement a sequence-to-sequence model using DeepPavlov library. First of all, I would like to remind you what is the sequence-to-sequence model. Sequence-to-sequence models are used when you want to produce output sequence using some other sequence as input. For example, machine translation task. Sequence-to-sequence models consist of two main components, encoder and decoder. Here you can see that encoder takes as input sequence ABC, encodes it to its hidden representation, and then this hidden representation is used in decoder to produce output sequence. Decoding process stops when model outputs end of sequence token or when sequence length reaches maximum value. On this slide, you can see modern sequence-to-sequence architecture. I took this picture from the paper about Google's neural machine translation system. You maybe used this model when you try to translate something using Google's translator on their website. As you can see here, we can find the same building blocks encoder and decoder, but they become deeper. Here we have 8 LSTM layers in encoder and 8 LSTM layers in decoder. Also, we can see here some skip connections, and encoder uses first two layers are bidirectional. Also, attention mechanism plays an important role here. You have already met such DeepPavlov abstractions like dataset reader and dataset iterator and others. In this tutorial, all dataset preparations and dataset preprocessing is done for you. Your task is to implement sequence-to-sequence model, to implement encoder, decoder, teacher forcing, and attention mechanism. Okay, now I will give you some details on how to implement encoder. First of all, you should define a recurrent cell you want to use. For example, it can be a GRU or LSTM or even a multi-RNN cell. Then you should use TensorFlow dynamic RNN to encode input sequence with this encoder recurrent cell. And encoder should return encoder outputs and encoder state. The next building block is a decoder, and the decoder uses encoder outputs and encoder state. One of the simplest way to implement decoder is just to write a Python loop and iteratively call decoded cell on its own output. And finally, decoder should return predicted tokens. They will be used at inference time, and legits. They will be used to compute a loss function. A few words about teacher forcing. There are two main there are two ways on how to use decoder outputs during training time. For example, in the simplest case, the model can just use its own outputs as the input on the next time step. The second way is to use not its own outputs, but to use ground truth labels, ground truth tokens in the case of natural language processing tasks. The last way is called teacher forcing. The main difference between these two approaches is that during train and test time, in first approach, we have the same computational graph, but in the second approach, during train and test time, we have different computational graphs, because during test time, we don't have these ground truth labels. During test time, we should use also this approach. We should feed our own outputs from previous step on the next time step. Attention mechanism. Without attention mechanism, decoder could use only last hidden state of encoder. But attention mechanism gives access to all hidden states of encoder simply by computing a weighted sum of encoder states. How to implement this attention? We will define a function .attention, which this function takes as input memory. In our case, memory is encoder states and current decoder state. And as I said earlier, we compute attention as a weighted sum of memory items. But how to compute these weights? To compute these weights, we can use some scoring function between decoder state and element in memory. For example, such a scoring function can be simple just dot product. After we computed these weights, we should normalize them by applying a softmax function, and then we can compute attention vector. So this function should return attention vector and attention weights. Attention weights are these alphas. So let's put it all together and build a sequence-to-sequence model with attention and teacher forcing using DeepPavlov library. Thank you. Any questions?